Good afternoon, students. Am I audible? Good afternoon, students. Am I audible?
Very good afternoon, ma'am. You are audible.
Hello. Okay. Clearly? Okay, let us start with the today's class. So today we are going to start with the second and third experiment. In the first experiment, we have seen about creating a database by using DDL queries, that is data definition queries, and also we inserted some data by using insert, update, delete queries, etc. So whatever our second experiment is there, that is a data manipulation queries. Data manipulation, it means that how we are modifying the data. So here mainly update, insert and delete queries are there. So already we have seen the variations within those queries where we can pass the conditions, we can have conditional delete or conditional updates, etc. So here in the DML, the main focus is given on the SQL select query. Select query, this is having the maximum variation, and that's why we are learning this query. So here, whatever the existing database is there, so this database already we have created. Previously also I have given instructions for creating this database. This is a university database schema, the department relation, instructor relation, course relation, next section relation and teachers relation. These relations I have asked to create, and these are the same from the textbook. So thing is that I have created a separate word file for this, and based on this schema only we are going to define select queries. Okay, so the same schema up to now wherever we are discussing, for that purpose only we are writing the select queries. So let us go through these queries, or first we will go through the statements and then we will go for the queries. So instead of going through the data, so previously I have given this schema also. So department relation contains three columns: department, department name, building and budget. So these three columns were there with data types given as a next to that varchar, varchar and numeric. So here this was the command to create the table. So create table, department name varchar, building varchar 20 which is not null, budget numeric 12 comma 2, and department name is a primary key. So this was the create table command. Next, instructor relation is there. In the instructor relation we are having id, name, department name and salary, where id is a primary key and name is not null and department name is a foreign key. Okay, so these are the attributes of the instructor. Then course relation, in the course relation whatever bold is there, that is a primary key. Title is not null and department name is also a foreign key, and credits, this is a integer value. Next, section relation. So section relation was having a composite primary key. Composite primary key, course id, section id, semester and year. So these are the four attributes combinedly forming a primary key of the section. So here if there are multiple attributes forming a primary key, that primary key will be called as a composite primary key. And here it is mandatory that we should define a primary key by using a table level constraint. Okay, so table level, it means that we are defining all the columns initially and then we are defining the primary key. So if only single column is primary key, during the definition only we can pass that primary key constraint. So just like here I have given this definition that id is a primary key. So I hope this is visible to you. id int primary key, during defining the column if we are passing the constraint, that will be called as a column level constraint. And if we are defining And if we are defining the attribute during uh, at the table level, that is after defining all the columns, then this will be called as a table level constraint. So these constraints already we have seen during the create table command. Now we are moving towards the uh, this composite primary key. So this is how we can define the composite key. So core side is a foreign key, so this is being referred here. So similarly, teachers relation also we have defined. Teachers relation, so this is also as having a composite primary key as well as composite foreign key. So here the foreign key, course id, section id, semester and year, so which is a primary key of the uh, section relation that was being referred here. So here the main point I would like to say is that here whenever we are defining a composite primary key, right now the section relation is there. Within the section there are four attributes are there which are forming a primary key. Now here the question comes whether we need to define all the attributes into the next table wherever that is referencing relation. Yes, here the main point is that we cannot refer the partial key. Partial key, if I'm having the four attributes into a primary key, I cannot take any of the two attributes into the foreign key. Here foreign key should be a complete primary key from some another relation. Either complete primary key or either complete candidate key it can be, but a partial key concept we cannot refer to some another relation. So that's why here whenever we are learning this, always remember that whenever we are defining the composite primary key, partial key we cannot refer to some another relation. And that's why here whenever we are defining the teachers relation, this was having id as a primary key of the instructor relation, and remaining four attributes are from this section relation, which is a primary key of that relation. So okay, so now I hope already you might have created these tables previously. So now so this is a data set. So this data set already I've given during the previous lectures, and I hope you have created the database. So this was available in the textbook also. And now we are moving towards the queries. So first query, so total queries are divided into three subparts: simple queries, intermediate queries and difficult queries. So let us first see the first part, that is a find the names of all instructors. So let me know who is willing to answer this question. So if consider anyone would like to share their screen during the execution, they can. So here I hope you have opened your laptop and started executing these queries. So first is find the names of all instructors. So who will answer my query? Either you can type the query in chat box or either you can share your screen. Either way you can. So answer for the first query.
Ma'am, ma'am, Ma'am,
Audible?
hello, ma'am.
Hi, yes.
Yeah, means before some before some minutes, means I called various times, ma'am. You didn't respond me.
Uh-huh. Actually, my pin got properly
Actually, what
not.
I thought, like my voice is not getting to you.
Only once I have listened your voice, and again later on I called many times. What is the problem? Please. After that, I didn't listen anything. I only once listened your voice.
Ma'am, means your voice is not getting to me. That's why, like, I think this is network issue.
Okay. Now is it clearly
So,
audible to you?
yeah, ma'am, it is.
Okay.
Ma'am,
Okay.
I want to answer the uh, what answer of first query.
It means you wanted to present your answer.
No, ma'am, means just by telling means what we can say. I didn't created the database of it, so I'm unable to share my screen.
Okay. 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 You have answered
So
in a chat window.
yeah, means that's why means what I thought like I'm disconnected or there is a network issue on my side. That's why I
Ha.
unmuted myself and sometimes called ma'am, my voice is
Ha. Ha.
getting to you or no?
No. 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 Now you are
And
audible.
you means you have taken wire clause now. That's why I'm confused. Like why here
Ah.
need of wire clause?
Actually, the thing is that whenever it means where clause is optional or compulsory, that initially we cannot
Yeah,
decide. Where to put the condition, that we will see during the explanation. Right now, here I
yeah,
have
ma'am.
given
But
the basics.
for first query it is not necessary to. Why we need the
Yes,
wire
yes.
clause? Hmm.
Here,
Okay.
I have started with the explanation that always we need to create a skeleton or model. Okay, so basic form of the query is that this is the basic form, select from and where. So
Okay.
here right now, first differentiate between the given things. Okay, so now here I have been asked to find the names of all instructors. Okay, so find the names of all instructors means that I have been asked to take the name. I know that instructor name is available into the instructor relation. And here next thing is that I have been asked for the all instructor names. So here any specification is not given to me. And that's why here whatever where clause is there, this filter is at all not required. And hence only this much query is sufficient for the first statement.
Okay, mama.
Okay. So actually
Huh.
where clause is optional or necessary. That we are deciding based on the statement. For this statement, it is not required. But for the next statements, we may be requiring this. Okay, that's why initially first always write select from and where, and then we can start writing the queries.
Okay,
Okay,
ma'am.
so students, is this clear to you why we only written select name from instructor? Remaining students, is that clear why we have written only select name from instructor? Okay, at least one response I am getting regarding yes. So, okay, based on this, so remaining students, please answer for the second statement. Find the department names of all instructors. I can see the students are moving to the third query also. Jaideep, your answer for the third query is also correct.
No, ma'am. It's for second query.
No, it is not for the
No,
second
no.
query, it is for the
Yes,
third
yes, yes.
query. And
Me
whatever your
need ಬಗ್ಗೆ
attribute, your attribute department name, okay? Whatever department name is there, for that we are having attribute name as DPT department name, okay? Whatever attribute name is there, that you should add properly, okay? Your query is correct, but whatever department name attribute is there, and that's why here whenever we are defining the query, here properly attribute should be used, okay? So this was the first query. So let me know, anybody else is willing to answer the second query? Yes, second query, Tejaswini, you are right. Select department name from instructor, okay? So here I had not made any specification that unique department you should pass or only once you have display the department name. So here let us start with writing this query. So always whenever a query is asked, use the form select from and where, okay? These are the compulsory things initially we will write during writing the query, okay? So always whenever you are solving any database related problem, etc., always write these queries on your paper and then you can start. So here I have been asked to find the department names, okay? So department name, this is available into multiple relations. I'm having this available into department relation, instructor relation, course relation, etc. So right now here I have been asked department names of all instructors. It means department name, whatever we are requiring, this is from the instructors relation. So here we can write, I know that department name is available into department this attribute, and instructor relation we are right now referring for this. Now, as I have asked all the instructors, it means again where clause is not necessary. So this filter we will remove and this will be the only answer for the second statement. And if you, it means here specification is that all the department names, and again specifically I'm asking remove the duplicates. If it is asked to remove the duplicates, then we can use here distinct clause, okay? Distinct clause, so this will be get applied on the department name. So wherever there is a repetition name of department name will be there, so this will display each department name only once, okay? It will not repeat. If there are two instructors into a computer science, only one it will list into the output, okay? So this is regarding the second query. Any doubt in the second query? Okay, no doubt, I hope. So now let us move answer to the third query. Find the instructor names where the instructor is in the physics department. Okay, so again write the basic form of the query, select from and where. Okay, so these three are the clauses. So we have been asked find instructor names. Okay, so we know that instructor name is available into instructor relation, and name is the attribute which is referring to instructor name. So I can write here instructor. Done. Now the question comes, whether do we need to display names of all instructors? No. Here where the instructor is in the physics department. So okay, so here physics, this condition is getting applied. So here in the where clause we need to apply the condition that department name should be physics. So here we can write physics, department name equal to physics. Done. Okay, so clear with this three clauses, select from and where. So here department name, whatever the actual attribute name is there, that we should use. So here many of the students get confused that if department name, this is a string value, so why don't you enclose this into also or double unit comma. No, just like we are defining name, instructor, etc. So these it means my compiler know that this is a attribute name. My compiler also knows that this is a table name, and in the where clause also my compiler automatically assumes this as a attribute name. If consider there is any spelling mistake etc, in that case it will give an error that this attribute doesn't exist etc. But if you give properly attribute name, this will accept this attribute name. Okay, and at the end semicolon. Clear with the third query? Okay. Okay, regarding the third, many of you have given the answer correctly. So now here queries that find all instructors with salary greater than 90,000. Okay, dollar 90,000. So let us write a basic query, select from and where. Okay, so now the question comes. Here salary is with salary greater than 90,000. So here simply I can write the where clause that salary should be greater than dollar 90,000. So dollar, this symbol we had not added to the table, so we need not to mention here. Simply we can write the 90,000. Okay, and this data is available into instructor relation and the select clause. So now which attribute I should list here? So many of you have given as name, many of you have given as salary. So here thing is that whenever any specification is not given, any specification is not given, that here I am mentioning the instructor name, here I am mentioning the department name, here also I am defining the names, but here any specification for all instructors, I had not mentioned anything here. It means that the user or the questionnaire is asking for all the attributes, and that's why here simply writing salary or name is not sufficient. Here we have to use a star or asterisk symbol, declaring that we are requiring for all the attributes of instructor relation, and hence correct answer was given by Tejaswini. Clear with this? Whenever any specification is not given, that we need only name, we need only ID, or we need only department name etc, here specification is not given, it means that this query is asking for all the details, and hence this will be having a star symbol here. Okay, and whenever we are defining the salary etc, during the salary we have mentioned this as a simple integer attribute. So integer attribute doesn't accept any symbol like INR or rupees or dollars etc. So this is our convenience that this amount is in dollars, or our own assumption that salary is in rupees etc. But if I'm mentioning here that it is dollar 90,000, here I may expect that this dollar is my by default any uh, unit for the salary, and this if I'm writing dollar 90,000, this will not accept here because dollar is not part of my attribute values. So here I may make assumption that dollar is a unit, and that's why only I need to check whether salary is greater than 90,000. So here passing this symbol, that is also a dangerous part, so make sure that you don't pass this. And if consider specifically any condition is given that whatever salary is there, this is in the rupees, now convert into dollars, then you can apply. So you can take any attribute, or here you can multiply this with the 56 and check. If I'm assuming that dollar value is 56, if the salary is greater than 90,000, such assumption also you can make. So anyway you can go, but adding symbol to a query, that is not a solution. Clear with this? Okay, so right now I'm assuming that this whatever amount is there, that is in the dollars, that's why only this much we will ask. And now this query, find the instructors in physics with salary greater than 90,000. Who will answer this query, or any answer is already available? So here thing is that we are having two conditions. We need to check for the two conditions. Okay, so let us write the basic query, select from and where clause. Okay, so these three clauses we have written. So find the instructors in physics with salary greater than 90,000. No any specification which attribute to be displayed. So star, all the details are available in the instructor relation, so I will use only instructor relation here. Where clause, so now here I am having specification that instructors in the physics department, my first condition, and salary should be greater than 90,000. So here we are having two conditions, salary greater than 90,000, and one more, that department name is equal to physics department. Okay, so here now thing comes, whether do we need to combine this, how we can write these two conditions. So here whenever there are more than one conditions are there, we always use a connective or any conjunction, just like and or not, etc. So now here we are having all the instructors in physics, it means this is a compulsory condition, and along with that we need to check one more condition. So here we don't have condition that all the find all the instructors in physics or with the salary greater than 90,000. So here first condition is physics, and then we are having salary greater than 90,000. It means both the conditions are compulsory. It means both the conditions should be get satisfied, and hence we should use connective for two conditions by using a and symbol. So you might be thinking that department name, this is my first condition, and why you have written afterwards. So so here it doesn't matter. So A and B is also equal to B and A. Okay, and that's why either of you condition here and there, it doesn't matter. So this condition I need to check first, and then you can check this condition, and hence so this is how we are checking for the conditions. Clear with this? Yes, answer right. Yes, many of you have answered this question correctly. Yes, done. I have got many answer correct. So here we should use a and for combining two conditions, and here either word or either of the condition is not asked, that's why we need to use and only. Okay, so now here this condition, check the raise of salaries of all instructors by 15% and display instructor details. Anybody? Check the raise of salaries of all instructors by 15% and display instructor details.
Ma'am,
Yes.
uh, first of all, means we have to increase the salary by 50% and then we have to display.
Do you think that
Am I
we should?
correct?
Yes,
Or
yes.
it is already increment means in raised?
Here I have used the word as check. Okay, check it means that I need not to make changes to my table. Okay,
Okay.
if I'm saying that you must uh, update the salary of all instructors by 15%, then it means that we need to perform changes to the actual relation, and then we need to display. But here the keyword used is check. It means I need not to make any changes to my table. So how we can? Okay, so here I have been asked display instructor details. Okay, so in the instructor I'm having ID. So in the instructor relation I'm having ID, name, department name, okay, and salary. Okay, these are the attributes of the instructor are there. So I will go for the instructor relation. And as I have asked for all instructors, it means where clause is not required here. The thing comes how we can check the raise of salaries by 15%. Okay, so here one thing is that we need to make salary. Okay, salary should be equal to whatever the current salary is there plus salary multiplied by 0.15. Okay, 15 divided by 100 equal to this much. So it means our salary should be displayed by this amount. So we wanted to check the raise in salary by 15%. It means whatever this formula I have written, my salary should be displayed like something with this formula. So in the select clause, I have previously already during the SQL statements, during the study of SQL, we have studied that we can perform simple arithmetics as part of our select clause. So here, whatever this formula is there, this is equal to the salary. Okay, salary multiplied by 1.15. Okay, so it means here salary multiplied by 1 and salary multiplied by 0.5. I have taken salary in common and combined these two things. So this will give us the salary raised by 15%. So here we can write this expression here, salary multiplied by 1.15, and we can rename this as a raised salary. Okay, done. Let me execute this on the uh, server. Is this visible to you?
Yeah, ma'am, it's visible.
Okay. So here we are having instructors ABC, etc. So these are the existing salaries of the instructors. So now let us execute whatever the query we have written in this way. Okay, so in order to differentiate between the existing salary, I will again use the same attribute salary, that this is my original salary, original salary, and this another attribute as a raised salary. Okay, so here this is how we can see this original salary 23,000 etc, existing salaries, and this will be my raised salaries. So here whatever this raised salary is there, this will not perform any changes to our relation. So this will only limit it up to this query only, and it will not be a permanent change. Okay, if simply I wanted to check that what will be the new salaries if we give raise by 15% or 20% or etc. So in that case we can pass these conditions or we can check this updates by using a select query. So okay, so we were talking about this query. Whenever a check is, it means that this change is not a permanent change. This is a temporary change limited up to this query. Clear with the answer of the sixth query? Yes, no doubt. Okay, so let us go for the next query. So find the names of all instructor in computer science who have a salary greater than 70,000 dollar. I hope this query is exactly similar to this query. Fine. Simply here we have been asked for the names of all instructors. So again start the query answer with the basic form of the query. Select from and where. So we have asked for to find the name of the instructor. So write down the name. All the details are available in the instructor relation. So instructor relation here and where clause. So we are having all instructors in a computer science department. So we can pass the condition like department name equal to computer science. In this way, something like that. The department name is there. Here, in this way, the computer science department is use the same label or the way we have passed the computer science and who have salary greater than $70,000. So 70 salary greater than 70,000 done. Okay. So for a minute, go through these queries and then we will move to the next part, that is intermediate queries. So these queries where only single relation is used. For this purpose, I have called this as a simple queries. So wherever more than one relations are input, those we are categorizing into a intermediate queries. So shall I move to intermediate queries now?
Yes, ma'am.
Okay. Retrieve the names of all instructors along with their department names and department building name. So who would like to answer this query? So I will stop sharing the entire screen.
Ma'am, can you show this query once?
Now is it visible?
Yeah, ma'am.
If I share the entire screen, each time I go to the window, it means chat window, etc. Again, the statement will get hidden. That's why I shared only WordPad screen.
Ma'am, wait for a second.
Yes,
I have.
yes. Take your own time.
Yeah.
As this is intermediate query, I can give 2 minutes. Mm-hmm. So here, before starting the answer of this query, so let us go through the schema of both the relations. Okay, schema of both the relations, instructor and department relation. Okay, so in the list I have asked for the retrieve the names of all instructors. Yes, then along with the department names, yes, department name is also there, and department building name. Okay, these three attributes we are requiring. So first write this basic form the query, select from and where. Okay, so we need instructor name, so I can simply write name. Instructor department name I need, so I will write the department name also. So now the question comes, can I write the building name or building here directly? Because whatever the first two columns are there or first two attributes are there, these are available into instructor relation, but whether building name is available into the instructor relation. So here, whatever building name is there, this is not available into the instructor schema. It means if we write the building there, that won't help us. So here, building is available into a department relation. Okay, so it means that for this purpose, for knowing the building, we should have a department relation also in our from clause. Okay, and that's why here whatever the answer given into the chart window by you, that is a wrong answer. Okay, so here simply I will write the department as a input relation. Now the question comes, so here I have been asked along with the there it means instructors department names and department building name. So do you think that whenever we are performing or writing more than one relation names as a part of from clause, always here a cross product is taken, that is a Cartesian product is there. Cartesian product, it means that every attribute of this relation will be get combined with the every other attribute of this. In this way, do we want to join these two relations? No. If I'm having the biology department, that should be get mapped with the only biology instructor only. Now here we are willing to display a department name. Department name attribute is a part of instructor relation also, and department name is also a part of department relation also. So here whenever we are simply writing department name here, my DML compiler gets confused whether department name to be chosen from the instructor relation or whether department name should be chosen from the department relation. So okay, so first before writing this query, let us perform the Cartesian product of these two. So here, if consider we are writing select star from instructor and then we are writing department relation. Okay, so let us see what is the answer. So here, it means here department name, this will be a department name from the instructor and this will be a department name from the department relation, and hence this department name and this department need not to be same. This computer science is here and biology here, in history biology, computer science biology. So in this way we do not want to display the building name, we are displaying name of the instructor, we are displaying instructor's own department, and then we wanted to display a building for all the instructors, and hence it gets mandatory for us to check whether instructor's department name is matching with the department's department name. If both are matching, then only I will get the correct building name. Right now here history is located into Watson building, but actually history department, history, no, for the history which, sorry, history department is located into Painter building. Okay, so in this way we get a false data. And because of this, it is mandatory for us to check whether this department name and this department name should be matching. This department name is nothing but a instructor's department name, and this department name is nothing but a department name. And that's why here, whenever we are writing this query, first make clear whose department name you wanted to display. We wanted to display instructor's department name, so that can be accessed by using relation name dot department name. And here cross product we can perform, but along with the cross product we should also check the condition that instructor dot department name, sorry, instructor dot department name should be matching with the department name. Okay. So let us write this query into the PHP my admin and check whether can we get a correct answer. Yes, we come to know that Srinivasan belongs to computer science, and computer science building is a tailor. For the tally, we can check here. Yes, computer science is into a tailor building. Electrical engineering is into tailor. History is into painter, and music is into backward. And let us see whether we are getting the output in the same way. Yes, electrical engineering is into tailor. Biology is into Watson. Biology department is also in the Watson building. So in this way, we history is into painter. History is into painter building. Okay. So if you are getting confused that why we need to apply this condition, let us write this query once more. Okay. So here simply we'll make the change that we will not write a where clause, and both the department names, it means instructor's department name also we will display, and department name also we will display. Let us see whether what is the need of this equivalence condition. So here this is my instructor name and this is department name of the, why this doesn't get displayed? Okay, I forget the comma. Okay, and building from the instructor and department name. So here this is a department name of the instructor and this is a department name of the department, and because of the Cartesian product every uh, pair of the department get mapped with the every tuple of the instructor, and that's why these dual names are there. But we will get a correct answer whenever we are having both the departments matching, and that's why we need to pass this condition into where clause. Okay, so here we will get a correct answer, here we will get the correct answer, here also we will get the correct answer. So in this way we need to check for the conditions. Clear with this? Here that's why during the simple queries also I told you that I am calling these as a simple query just because they need only single relation for solving. Okay, all these relations, whatever the first 6 queries or 7 queries we have seen, all this taking as a single relation for the input, and that's why only I have called them as a simple queries. Now on that basis I wanted to give the hint that intermediate queries will have more than one relation. Okay, so now I hope you will write the correct answer for this query. So still if you are feeling the problem, please go through this query once and then you can go for the second question.
Ma'am, ma'am,
Yes.
can you show the database of instructor and department once again?
Yes, no problem.
Just for file.
Yes.
Department. Uh, just up the slide, ma'am. Just up it. Okay. Course relation. Okay. Okay, you can move to that page on which the queries are there.
Done. So, okay, before starting, make sure how many relations you need for your query output. Okay, this is the main thing. So here I can write the select, okay, from and where clause, okay, done. So now, can anybody explain me what is the meaning of this? Find instructor names and course identifier for instructors in the computer science department. So here, whether computer science department is for the instructors or whether it is for the course.
I think it is for instructor means department name.
Okay, and which course IDs I should select?
From course relation.
Yes, course relation, but which one? It means all course IDs I should select.
Who having the department as a computer science.
Okay, those course IDs who it means where department name equal to computer science is there. Okay, so now do you think that there are two queries combined into single, that instructor is also from the computer science and course ID is also from the computer science department? So do you think that these two are related with somewhere else? It means what
Means,
this statement of the query requires.
ma'am, course relation is required for it because we needed the course ID.
Okay. Okay, let us start with the what is required. Okay, I need a instructor name. I need a course ID. Okay, find instructor names and course identifiers for instructors in the computer science department. So here I know that name is available into instructor and course ID is available into uh, course relation. So now whether only this much condition is sufficient, so should I write computer department name equal to computer science? Hmm? Only this much is sufficient. Okay, not to confuse you more, I will write the schema of both the relations. Instructors relation schema, we are having ID name. Okay, name of the instructor, department name of the instructor, and salary. Okay, these are the attributes of the instructor relation. And course relation is having the attributes like course ID, title, and then department name and credit. Okay, these are the attributes of uh, course relation. So now, do you think that department name, simply if I write where department name equal to computer science, this condition we can pass directly? No. Here the thing is that department name, this attribute is available into instructor relation as well as this attribute is available into course relation also. So whenever we are writing department name equal to computer science, my DML compiler will give that this attribute is ambiguous and we cannot use that. It means it is unable to identify whether to take department name from the instructor relation or whether to take department name from the course relation. So in this case, we need department name from both the relations. Okay, so here randomly any course ID we cannot go for, and the implied thing is that whenever we are putting a condition on more than two relations, always we go for the matching of these two attributes, matching of equivalence of attributes where there is a matching attribute is there. It means here along with this we should pass here condition that we can take either instructor's department name or either we can take course department name. And one more condition we should pass is that here instructor, okay, instructor dot department name should be matching with the course dot department name. Okay, so here computer science, whenever a course ID is asked, here course identifiers for instructors in the computer science department. So this it means that definitely I'm checking for this condition, and whenever there is a matching attribute is there between the two relations, always we go for the equivalence of the values. And that's why here course dot department name, this condition needs to be checked. Okay, shall I repeat?
Yes, ma'am.
So here I have been asked course identifiers for instructors in the computer science department. Computer science department. So I have asked for the name listed here, course ID listed here. It means I will also say the course ID. So now this attribute is available into instructor relation and this attribute is available into course relation. Okay, but I have been asked for the department name of the instructor to be computer science. Okay, up to this part I think there is no doubt. but whenever it means implied, whenever we are combining the two relations, okay, two relations always say that here also we have combined these two relations by using a equivalence of common attributes. Okay, this computer science instructor may be conducting courses in other departments also, but here course identifiers for instructors in the computer science. This has been asked. It means that here we should check for the department to be computer science for the course also. Or the second option is that as two relations are having the common attribute as department name, we can check for the common of these attributes to be by using instructor.department name equal to course.department name. And hence we will also check here whether this is equal to computer science. And so we will get only those instructors with teaching the courses from the computer science only. That is instructor names and course IDs. Still in the doubt? Hello. Okay. May I move to the next statement? So here the next statement is that find all the instructors in university who has taught some course, find their names and course IDs of all courses they taught. Okay. Here for all instructors in the university who have taught some course, find their names, okay, names of instructors and the course IDs of all courses they taught. Okay, so read the statement carefully and start writing the answer for this query. Siddhali, you are joined too early.
Ma'am,
Yes.
can you write schema for it? Means for the current query which is going on.
Okay.
Means it seems difficult.
If I give the schema, I'm indirectly giving the answer also. Okay, still I will give this. I want you all to go through the schema. Hmm. These three relations. Semester year. Done.
Ma'am, now wait for a while. I write the query. I will write the
Okay.
query.
Yes,
Means
yes.
I only means what we can say. I only understood there are two relation. I means ma'am, I didn't find out in the query means how much relation. Means how much relation in the query. Like I didn't consider the teachers relation in the query.
Yes, that's why initially I have given that whatever the data set is there. Repeatedly, I was asking whether you have created this data set, whether you have created this data set. So here, first, before starting, not only to you, let me explain this complete schema to you. Okay, whatever this database it means that we are keeping this interrelated information at some place. Okay, so what your department relation is there? This was having information about the departments. Okay, next instructor relation. This was having information about the instructors, and this is also holding that which instructor belongs to department. Okay, so already department is my base relation. From this, I'm taking the department names here. Okay, so done about this. Next courses, this is again a independent relation. It means parallelly. First department name, this relation will come, and one hand instructor relation and one hand course relation will be there. So course it means that which subjects are taught in the university. So this subject introduction to biology is taught into biology department and which carries 4 credits. Genetics is taught into biology. So this course relation, this is holding information that which subject is taught into university, what is subject code and how much credit it takes, and this is regarding the course. So this is only maintaining the information about the courses. And the next relation section, this is maintaining the information that it means just like we are having the database engineering. So database engineering right now taught into year 2020 21 or 1920 or 1819. So here, this database is actually belonging to some outside foreign university. So they are having whatever our academic calendar is there. In the same way, they are having the academic year also. It means 2010, 20, January to December. In that way, they are having the years. And within that semester, we are having first and second semester. They are having the season-wide semesters. Okay, so this section relation is holding the information that this course was having the section ID 1. It means we are having 2 semesters in this. In the same way, we are having this 1 and 2 sections and semester. Within a one semester also we can have within a one section also we can have multiple semester. So semester in this year and at this building in this room number at this time slot id this subject was taught. Okay, so this is holding the information that which subject was taught in which building and in which room number. And then here comes the teachers relation. Teachers relation, this is holding. Now here right now we are having a b c d divisions etc. We are having a division, we are having b division, c division. So it might happen that A division was handled by some another instructor, B division was handled by some another instructor. So in the same way, teachers is holding this information. So teachers that this instructor has taught this course in this section, in this semester and in this year. It means this is holding who has taught which course. So up to now only this was the existing database which we are referring. So here the question is that find all the instructors in the university who have taught some course. Okay, it means that I must refer to the teachers relation because teachers relation is holding the information who has taught which course. Find their names. It means I will find the names of the instructors and course IDs of all courses they have taught. Okay, so it means that here I need to find out the course IDs. So now course ID, it means which subject they taught. That information is available into teachers relation. So here I have not asked course IDs and title. So it means I need not to have this course relation. Only teachers can give me the course ID. That's why this relation is sufficient. So here in the from clause, I will pass the teachers relation. And I need a name of the instructor and I need a course ID. Okay. So I will list those into the select clause. Now the question comes whether name is available into teachers. No, in the name I am having only ID of the instructor. Name is not available. So it means I am in need of a instructor relation also. So now the question comes, can we combine this instructor and teachers directly? No. I previously also mentioned whenever we are combining two relations, we need to check for the common attributes. Common attributes, here we are having the ID and here we are having the ID. So it means here we need to pass the condition instructor dot ID equal to teachers dot id. This last condition is required because whenever we are passing more than one relations to be as a part of from clause, this always perform a Cartesian product. Cartesian product, every tuple of the instructor will be mapped with the every other tuple of the teachers. So here I am having 101, here I may have 1234. So this in this way we do not want to list the name of the instructor. We wanted to list only those names where this ID and this ID is matching. Just like here also we have done this while executing this building name and department name. Similarly here also we will go for the matching IDs and then only we will display the names of the instructors. Getting heavy? Understood?
Yeah, ma'am. It's understood.
Need one more query?
What, ma'am? No, no,
One more
no
query.
need of another example of speech.
Okay, no problem. Hmm. Now this one is a somewhat difficult query as compared to the previous one. So here previously I was asking for the names of instructors and course IDs of all courses they have taught. Now here I need names of instructors along with the titles of courses that they teach. Okay, it means here we need a course title here. Okay, so start writing query for this statement. Anybody still want to take a chance to solve the fourth statement? Fourth statement. So list the names of the instructor along with the titles of courses they teach. So now here let us write a basic form of the query. Select from and where. Okay, done. Now here we have been asked to list the names of the instructor. So I will list the name and I need a title. So these two things I have written. So now next comes name of the instructor is available into instructor relation. So I will pass this information. Title of the course is available into course relation. So here also I will pass the course relation. Now the question comes courses that they teach. Okay, the courses that they teach. Now the question comes with it, do we have the information that simply based on the course ID we can guess which course is taught by the instructor, or based on the ID we can decide which course is taught by the which instructor? No. Based on the instructor and course, this doesn't carry the information that which course is taught by the which instructor. This information is available into teachers relation, and this is having the information that which course ID, that which instructor has taught which course. Okay, that's why here, and our question is based completely on the course that is taught by the instructor. It means that here we need a three links, that I will select a course ID. Sorry, let us take a one way, that this instructor, I will check whether it has taught any course. If this has taught any course, get that course ID and check the title of that course into the course ID. Okay, it means here first I need a instructor relation. Within that I will choose an ID. Based on that ID I want to select the name. So ID I will choose. On basis of that ID I will check whether entry is available into teachers relation. In the teachers I will compare this ID equivalence and I will get a course ID. And based on this course ID I will check into course relation. Okay, and there I will confirm for the equivalence of course, and from that I will get the title. Okay, this is how the flow takes place, and that's why here only these two relations cannot give us the which course has been taught by the instructor, and that's why here we will write a teachers relation also here, and here we need to write the complicated query like instructor. Okay, instructor dot id should be matching with the teachers dot id, because we need equivalence of IDs, else it will perform the Cartesian product which we don't want. And whatever the teachers course ID is there, teachers dot course ID is there, that should be equal to the course dot course ID. Yeah. So this is the flow of the information, and this will be the actual query. Got the answer? Getting the answer? If you are feeling this difficult, let me know. Clear with the answer of the fourth query? So try to solve the fifth query and let me have the answer of the fifth query. So consider a query to find set of all courses taught in fall 2009 semester and spring 2010 semester. So here I have not listed what to be displayed. So you can take course ID simply to display. Find the set of all course IDs. Okay, starting fall 2009 semester and the spring 2010 semester or both. It means for up to this much we are having OR condition, and here for both we need a AND condition. Start writing a query. I will wait for the 2 minutes. Why you people are giving the attendance? I'm having automatic attendance mechanism. Whenever I'm asking to give it, simply that time only you can give the attendance. Do not give attendance in the chat window. So okay, let us move to the answer of the next query. So here we wanted to list those courses uh, which are taught in the fall 2009 and spring 2010. Okay, so we are having the course CS 101, the first answer, CS 315, next CS 347, finance 201. So all entries are like that only spring up to this point, all course IDs, and then next this one, spring 2010 CS 319. It means how many entries we are having? CS 319 1 and 2 3 4 5 6 7 8 9 and 10. Okay, total 10 entries we are having which are taught in fall 2009 or spring 2010. So if consider I'm computing this answer, okay, uh, then we are getting total 24 rows as per the answer given by the uh, Tejaswini. That is, we are having semester equal to for semester equal to fall and year equal to 2009, or semester equal to spring and year equal to 2009, and course id equal to teachers course id. So first thing is in the question, what is it required? Find a query to find the set of all course IDs taught in for 2009 semester and spring 2010 semester. Now the question comes, do we need a course relation here? Why we need course relation? Because in the teachers, okay, in the teachers I'm having semester, in the teachers I'm having year, and I'm having course ID also. Then what is the need of my course relation? Neither I need title, neither I need department, neither I need credits. Then why the course relation you have taken in the answer? Okay, That's why here we need only a teacher's relation as an input relation. So here let us write the query answer. Select, okay, course ID from teachers, okay, and where semester equal to okay, fall and year equal to 2009. Okay, this is our first condition. Now, do you think that here I should write the or condition and again write semester equal to spring, okay, and year equal to 2010. So now, how many think that this can be a true? Okay, let us write this query in the command prompt. Whether PHP MyAdmin is visible to you. So this one is the answer. Total we are having 7 rows. Few of the rows may be deleted by me. So the SQL query previously I have written is this query. Here I need only teachers relation because I have only simply asked for the course ID, and that's why we did not to have a course relation etc. Simply I have listed this into the intermediate query. It doesn't mean that this requires more than one relation. No, here course ID is required, but the condition is complex. That's why this statement was included into intermediate queries. Ah, yes. For the or, this one is a very simple query, but for the and, okay, when the clause comes as both, okay, for both, this is definitely a difficult query. So now, for the and, the condition says that semester equal to fall and year equal to 2009, semester equal to spring and year equal to 2009. So do you think that this and condition can come to any time? So okay, the thing here is that this we cannot write this condition. So let us study about the operators, okay? How the or operator and how the and operator works. Okay, these two are the binary operators on which one side one expression is there and another side another expression is there, and also here this one is having one even expression on the left side, and this here e2 expression is also there on the right hand side. So here whenever these two operators in the programming languages whenever are working are following the rule that first see about the or. So in the or we know that either of the condition is true, the result will be true. If consider this even expression got true, okay, so in that case it doesn't look for the e2 whether e2 is false or true. Without any consideration or without any checking for e2 to true or false, simply it adds that to be true as true is the answer, because for the or single input is true, then also this is true. And that's why here whenever the first expression is true or doesn't compute for the second expression. And in case of and, exactly reverse or same follow strategy is applied. If condition first, that is expression is false, it doesn't compute for the e2. simply it marks the given output to be false, saying that for the and we need every output to be true, and that's why even first is false, let it be second true or false, it doesn't matter for the and. If first one is true, then only it goes for the computation of the second one to be true. And that's why here, if first condition is true, fall equal semester equal to fall and year equal to 2009, having semester equal to spring simultaneously taking two values for a single attribute is not possible. And that's why here, whatever the remaining part for this one, wherever or is there, for this the answer can be written by using a simple query also. But for and condition, we need to go for much more details. And that's why we will stop here today. The remaining discussion we will continue tomorrow, and some more queries, some more data set we will go for, and then let us check whether it feels comfortable for you to go for the SQL queries. Today we will stop our class at this point only.